Already in the previous session we dealt with the calculation of molecular weight, mole and equivalent weight for the acids, bases and salts we have seen. Now we are going to see how to calculate the equivalent weight for the oxidizing substance or the reducing substances. Okay, so because in redox reactions, depending upon the medium, the number of transferring electron will vary. Okay, for example, here I have taken KMnO4. So let's see how KMnO4, depending upon the medium, how many electron it gives to the other substances, or how many electron it takes up. So we'll see. Okay. So first, to calculate the equivalent weight of KMnO4, we have to know the molecular weight of KMnO4. So molecular weight of KMnO4 is equal to, so potassium is 39, manganese is 55, and oxygen is 4 into 16. Okay, so this will be 39 plus 55 plus 64, that is equal to 9 9s are 18 plus 1, 6 6 are 12, 12 plus 3, 158. So 158 is the molecular weight for the KMnO4. So now we know the KMnO4. Depending upon the medium, we are going to see how it takes up the electrons, or how many electrons are transferred in the reaction, that we are going to see. First we will take the acidic medium. So in acidic medium, KMnO4, let's write KMnO4 minus 1 plus H plus electron minus gives Mn2 plus 4H2. If you see in this reaction, there are charges like one extra charges. Here is overall minus 1, here plus 2 is there. So we have to nullify the charges on the both the sides. Okay. So as it is, there are what you call 4 into 8 hydrogens. So we have to supply 8 H plus. So when you sum it up, how much charges it is coming? So it is coming as 8 plus minus 2, so totally 6 charges. Okay. And here this side what you have is only plus 2. Okay, so when you supply the electron 6 2. Okay. Now when you put 5 electron, what happens? So this one is minus and this also minus. So totally minus 6 and plus 8H plus. So overall charge will be plus 2 in the left hand side. Right hand side also, if you see, this is overall 0 and you have only plus 2. So hence the equation is electrically neutral. So now this equation is balanced. And in this reaction only 5 electrons are transferred. Now the equivalent weight is KMnO4 is equal to, in acidic medium, molecular weight of KMnO4 divided by 5. So 158 divided by 5. So 3 5s are 5, 1 5 is, remaining is 3, 6 5s are 30. So this is the 31.6 is the in the acidic medium. Okay. Now let's see in the strong basic medium. Okay. In basic medium, MnO4 minus, it takes up, it becomes 1 electron minus, it becomes MnO4 minus 2. Okay. So the equivalent weight of KMnO4 in presence of strong alkaline medium or strong base medium, molecular weight of KMnO4 divide by only one electron is transferred, so it's a 158. Now we'll see in the neutral medium or mild alkaline medium. Very feeble alkaline or neutral medium. MnO4 minus plus, here it becomes MnO4 plus 4OH minus, here 3 electrons are transferred, so charges 4H2O. H2OH. Sorry, MnO2. Okay. So here only 3 electrons are transferred, so the equivalent weight it will be in the neutral medium. Molecular weight of KMnO4 divide by 3, so 158 divide by 3, 5 3s are 1, 2 3s are 6, so remaining is 2, 6 3s are, so 52.66. So if you see any oxidizing agent or reducing agent, water oxidizing agent, they oxidize, it itself get reduced and it oxidizes the other substances. Okay, so and for acid and bases and salts, we have fixed either acidity or basicity or number of charges, but for the oxidizing agent and reducing agent, depending upon the medium, they transfer the number of electrons, so accordingly we have to write their equivalent weight. So hope you understood this equivalent weight calculations. So in the previous video we calculated molecular weight for the acids and bases and equivalent weight for the acids, bases, salts. Now for the oxidizing agent. Now we know what is molecular weight, equivalent weight, moles. Now we are going to the gram equivalents. So what is mole? Mole is given weight by molecular weight. So what is gram equivalence? Given weight by equivalent weight. Okay. So when you dissolve this mole in liter, that's called molarity. When you dissolve mole in a kilogram of the solvent, that becomes molality. So here when you dissolve the gram equivalence in 1 liter, that becomes the normality. Okay, so this is the connection. So once you know the molecular weight, we can calculate the moles. Once we know the equivalent weight, we can calculate the gram equivalence. So for example, we can how do we calculate the equivalent weight for the oxalic acid? And from there we are going to prepare some certain concentration, normal concentration of oxalic acid. For example, I need to prepare 1 molar of oxalic acid. For that, how many grams are needed? And I also want to prepare the 0.05 normal of oxalic acid in 1 liter. So for that, how many grams are needed? So I am going to prepare the 2 concentration. Okay, so to prepare 1 molar of oxalic acid, first we will go So oxalic acid is COOH, it has the 2 water molecule. So when you calculate their overall molecular weight, it will become 126. You can try yourself. So total molecular formula I write H2C2O4 dot 2H2O. Okay. So 2 plus 24 plus 64 plus 36. 1 water molecule is 18. So 2 water molecules. So if you sum everything, 8, 10, 126. Okay, I'll get 126. So I got 126 as the molecular weight. Okay, molecular weight of oxalic acid is 126. So if you weigh 126 gram of oxalic acid equal to 1 mole of oxalic acid. So I took 126 gram if I weigh it, and if I dissolve it in a 1 molar, so 1 mole of oxalic acid, if I dissolve in 1 liter of the water, I get the 1 molarity. So I have to take 126 gram in 1000 ml of water, I get the 1 molarity. Okay, so next concentration what I gave you is the 0.05 normal. Okay, so first we will calculate what is 0.5 normal. So as I said, it is oxalic acid is a diprotic acid. So equivalent weight of oxalic acid equal to molecular weight of oxalic acid, because it has 2 protons. This is water of hydration, this is 2 replaceable protons. So 126 by 2, so we get 63. Okay, so the equivalent weight of oxalic acid is 63. Now if I need 1 normal, how much I have to weigh? I have to take 63 gram in 1 liter. Okay, so that is for 1 N. So 0.5 N in 1 liter means I have to take even half of this. So that will be 33.5 grams in 1 liter. So what I asked 0.05. So I have to take another digit of, so 1.315 gram in 1 liter makes the 0.05 normal of oxalic acid in 1 liter. So it's a direct proportion method, you can just calculate it. First you have to know how much amount required for one molarity, how much amount is required for 1 normality. From there you can directly divide or you can just multiply, you will get the corresponding normality and molarity. Okay, so hope you understood this video. Thank you.